Hello, my name is Asad Ali Mirza and welcome to Narrative Learning. Today I'm going to talk about application of blockchain. But before we go into detail, let's discuss what blockchain is. Blockchain is a technology that enables us to move resources on a provided decentralized database. Now these resources could be anything that provide us value. The resources are transparent among the parties or nodes that are involved, which makes it a more trusted system. The concept of blockchain was introduced in 1991 by a group of scientists who proposed to timestamp documents digitally in order to validate them. Once a document was timestamped, a hash of the complete document was calculated. This hash was used to validate the document. Any tiny change in the document will change the hash and it will invalidate the document. Unfortunately, blockchain was not practiced that much until 2009, when Satoshi Nakamoto created Bitcoin using blockchain technology. Now that is a very important point here about a very general and common misconception between Bitcoin and blockchain, that they're one of the same things, but they're not. Bitcoin is not blockchain. Bitcoin is a digital currency, whereas blockchain is a technology used by the Bitcoin. Now that we know a bit background of the concept, let's see an aerial description of the concept to get more detailed idea. To understand this more detail, I have prepared a case study. In this case study, we're going to discuss a very basic example of money transferring. The scenario is we want to transfer money from point A to point B. So let's say A is in Sweden and wants to transfer $5 to B in Pakistan. As there is no direct line, so A will have to use a third-party service. $5 will be transferred via the third party who will transfer the money to B in Pakistan. Let's say the third party charges some fee, and after that, going to take 2 days, and then it's going to transfer $4 to Pakistan. Now, during those 2 days, you don't have any transparency on what the third party is doing with your money, or is the money transferred or not. In this example, we touched 3 general problems, and those are time that the third party took, what it did with your money during that time, and the fee that it cost you to transfer that money. Now let's address these problems in more detailed way by considering another example. So we have 3 persons here, A, B, and C. In the very beginning, we say that A has $10. We're going to maintain this in a record, which will be our open ledger. That will be on the right-hand side. B has $7 and C has $5. Let's say A wants to transfer $7 to B. The address of A, B, and C are basically the public keys on which the money is transferred. This will be added as a transaction to the ledger and the transaction is performed. So when A transfers $7 to B, it's going to look like this. B wants to transfer $5 to C, which will also be added to the ledger, and so will our last transaction, that will be C to A. That is also $5. Now if you see, this open ledger is actually the transfer transaction, which is done instantly. This open ledger here is called the blockchain. So we have fixed the problem with the long transaction time by instantly maintaining the record in an open ledger, but our solution is still like the third party, where our ledger is hosted at one place, which could be a single point of failure. So let's discuss that now. To address this problem, we will distribute the ledger to each node that is involved in the network. So A, B, and C will have the copy of the ledger. So now we have distributed blockchain. By doing that, we eliminated the problem of trustless ledger. In fact, now it is more visible to all parties and they can validate the ledger anytime. As we have solved this problem by distributing the blockchain, we yet introduce another problem of synchronizing the ledger so that it is updated on each node on the network. The problem here is that A can say that C transferred $10 to A and add it to its blockchain. So how will the other nodes know that it was an invalid transaction? To understand this part of the system, where we will have to look at another example. Let's say this is our network with nodes and their respective blockchain. Let's say A wants to transfer $2 to C. When the transaction occurs, a block is created, but not yet validated. The difference between creation and validation of the block is that anyone can create a block, but it has to be validated before it could enter to all the blockchains. When the block is created, it will be distributed to special nodes in the network that will perform the validation. These special nodes are called miners. Miners are just ordinary nodes, except that they have high computational speed to compute the validation of the block. Once they validate a block, they are rewarded with a small amount. For our block, we have to calculate the hash of the block, which some could say is a really quick operation, so why this high computational power is needed? Usually there are some blockchain rules that are enforced by the blockchain or block validation that the hash of the block should start with 5 zeros. This is called the difficulty of proof of work, proof of concept actually. I will discuss these topics in detail in my later videos. Let's get back to our block. So once our intended block is published to all the nodes, all the miners will pick it up and start computing the hash of the block. Let's say B was able to generate the hash before D. So B will add it to its local blockchain. B will add the key that is used to generate the hash, add it to its local blockchain, and broadcast it to the network. Observe that all the blockchains are updated. When A receives the block, it will validate the hash by using the same key in the block, and once validated, A will add the block to its blockchain and wait for the next block. The reward system for the miners is very complex and very important part of the block because it contributes to your currency. So now we have discussed and addressed the principle of blockchain, validation of block, and distribution and synchronization of blockchain. I hope you understand this high-level description of a very complex framework. If you have any comments or questions, do mail me. My name is Asad Ali Mirza, and this is Narrative Learning.